Most materials, but especially metals, are affected by temperature. As temperature rises, they expand or increase in size. As temperature falls, they contract or shrink. For most, these changes will go unnoticed in everyday life for two main reasons. Firstly, the changes in dimensions will be so small it will have a limited effect. Secondly, the change in temperature has to be fairly significant to drive any meaningful change. But for engineers in a number of areas, thermal expansion is a major concern and something that has to be managed carefully. It has to be managed carefully because the forces involved can be huge and devastating if misjudged. On the railway, the track consists of rail, laid out in all weathers, from hot summer days to cold winter nights. Management of the thermal forces within these rails is an area of focus for railway engineers. In this video, we're going to look at stress-free temperature, a phrase you might come across and key to the use of continuous welded rails. Continuous welded rails are effectively long beams laid out parallel to each other. While CWR has many advantages, the strength of the rail in compression, when it's being squeezed from each end, is not one of them. If a rail is installed at 15 degrees, when its temperature falls below 15, it will go into tension, as it and the rails around it contract due to the cold. When its temperature goes above 15, the rail material expands, which creates compressive forces due to it being restrained at either end by a rail either side of it, and the fastenings holding it in place. It is only at the 15-degree point that this rail is free of any compressive or tensile forces. These forces can also be known as stresses. This temperature, then, is known as the stress-free temperature. So why is the stress-free temperature a fixed value, and how is that temperature determined? The SFT is fixed to ensure uniform response and performance of the sections of rails within a track to changes in temperature. Imagine if you had rails installed at different SFTs that would all start contracting and expanding at different temperatures. It would be impossible to predict the response of the rail to hot weather and therefore impossible to mitigate the risks. The temperature used as the SFT is picked based on the overall climate of the country or area in which the railway is situated. A starting point to consider is the lowest and highest temperatures. This will be where the maximum forces or stresses occur. The midpoint could be then used for the SFT. If a temperature too high is picked, rails would snap under high tensile stresses when the temperature drops to their lowest point. If you don't pick a temperature high enough, and the risk of buckles increases in the summer heat. So you can see it's a balancing act. In the UK, the SFT is 27 degrees. Drop in the comments below your country's SFT value if you know it. Some countries and areas have such an issue with the temperature ranges that they experience that they undertake a programme of stressing, both at the end of winter to prepare for summer, and then again at the end of summer to prepare for winter. Given that the change in climate means we're experiencing higher summer and lower winter temperatures, it's likely that well-established SFT values will have to be adjusted, or seasonal adjustments may become the normal for everybody. Thank you for watching this video. I really hope you have found it useful. Please do drop a comment below with any questions or queries. Hit that thumbs up like button and subscribe to ensure you don't miss my next video.